Hello, everyone. Thanks for joining us today. So this is a fourth day of our summer marathon. So this is the first week where we talk about career in data. So we already had 3 talks. So on Monday, we talked about transitioning from software engineering to machine learning. Then on Tuesday, Daliana was talking about getting a promotion. Yesterday, Andreas was telling us how data scientists can learn to build data pipelines. And today we will talk about 2 roles. We will talk about the role of data engineer, and we will talk about the role of data scientist, and we will compare them. And tomorrow, Elena will talk about building a machine learning startup. So I would like to thank all our partners who made this event possible, who helped us spread the word about the conference. Please check them out. There is a link in the description about the conference. If you click on this link, if you scroll down, then you can click on the logos and see what they're doing. Subscribe to our channel not to miss any new events. We do streams regularly, and join our Slack to talk about data. And finally, during today's interview, you can ask any question you want. There is a link in the live chat. So just click on this link, ask any question, and we will try to cover these questions during the interview. And that's all I have for the introduction. Are you ready to start?
Yeah.
Okay. So just 2 minutes. Okay, we have today we will talk about the difference between big data engineers and data scientists, and we have special guest today, Roksolana. Roksolana works as a big data engineer in Captify, right?
Yeah.
And so today she will talk about the role of a data engineer and data scientist. Welcome.
Thank you.
Before we start with our main topic, let's talk a bit about your background. Can you tell us a bit about your career journey so far?
Yeah, sure. So I have a software engineering degree in one of the Kyiv universities. It's both bachelor and master's degree. And after that, I was working for some time as a backend engineer in Java mostly. And just at some point, I learned about data science, big data engineering, and I had some time to make a decision what exactly I would want to do. And kind of backend engineering at some point just got a bit boring for me. So I switched into big data engineering, learned Scala programming language. And that's my main programming language now. And for a few years, I worked at a company called Cyclum. It's quite famous in Ukraine because it's quite a big company, one of top 5. And it's an outsourcing company which works with clients and as well as has some research. So I was working at the R&D department. We had some internal research stuff, and also I worked for some client projects. And only 2 years ago, I joined Captify, which is a product company. They're building a product in the sphere of advertising. And actually, the company is British. It's based in UK, but it has a part of the engineering team in Kyiv, where I'm based, and mostly working on the product part, specifically in the big data engineering team.
Yeah, I've heard that in advertising there is so much data that this big data engineering becomes really important, because these companies every day get terabytes of data, and they need to effectively process this data, right?
Yeah, and also what kind of makes the solution of Captify unique is data insights, which are obviously delivered with the help of big data engineering team by having different sources of data and ways to transform this data and deliver it to the clients.
So what do you do at work? What do you usually do as a big data engineer?
So my main responsibility is building data pipelines. Usually it's ETL format, extract, transform, load. So kind of reading the data from some source, building transformations, some aggregations, and uploading it somewhere which would be available for other users. It can be a relational database, or it's often just data storage like HDFS or S3, and users can query the data using query engines like Impala. So usually we kind of service in such a way the data to the analyst team, so they could run queries and build reports. That's kind of the main responsibility. Aside from that, we have some internal libraries development, researchers, like for example, right now I'm working a bit on the Delta Lake introduction from Databricks. And also we have like either some features added, some small fixes because it's a bit of legacy code already. The product is quite stable. And also some new creation of new pipelines or just redoing kind of the existing infrastructure. Sometimes we just rewrite in some parts to make them more performant. So optimizing performance of existing pipelines is also a big part of the job, especially during some production incidents or just when you're seeing that something performs not as good as it's supposed to do.
Mm-hmm. So basically your main job is, so there is some raw data that is coming from your product that users of your product generate. And your job is to take this data, convert it, you said build these data pipelines, ETLs, such that analysts or other users who need to analyze the data, they can use tools like Impala to access this data, run SQL queries, and get some insights, right?
Yeah,
Well,
for the most part.
Yeah, you also maintain this Impala to make it possible for them to do queries?
Partially it's work of the infrastructure team, but we kind of work mostly on optimizing queries and jobs in such a way that other users would be able to run their queries, because if our jobs would take like too much resources, it would be impossible for them. But we set up our own Spark jobs and optimize them in terms of resources, like for example, how many nodes in the cluster we need, how we want to scale that, and we decide for our own jobs and their performance that we want to get less or more resources, and that we want to optimize it using Spark capabilities, so just improving the code base.
Mm-hmm. So what kind of tools you use? So you mentioned Spark, you mentioned Impala, you also mentioned HDFS and S3. What else do you use for that, for doing this, creating these pipelines?
And those are like the main ones. Aside from that, some AWS services like S3, some services for Spark setup. Spark is built using Mesos for now. We have a bit of Kubernetes, mostly for metrics and alerting system like Prometheus, Grafana as well. And we have some backend libraries for the part of data parsing, like Play in Scala, or libraries for tests, which are also Scala libraries like Scala test and all of that.
Mm-hmm. I remember you have a talk about, what is it? I think it has a funny name about Alice discovering Kubernetes. What's the name of this talk?
I think I have like a series of those. Probably it was the first one when Alice learns the difference between functional programming and Kubernetes, something like that.
How did you come up with this idea by Alice?
I don't know, it's hard for me to say. It's kind of a cumulative experience, because before I started to speak at conferences, I visited like tons of local and European conferences, and I noticed that it's much more interesting to kind of get invested into the story aside from the technical side. And that's how I tried this idea with the first talk. And only after some time, I decided that probably I need to build more of those. And then it kind of spiked the popularity because people enjoyed a lot the story side as well.
Okay, so it became like a brand, like this kind of,
yeah.
Okay.
Yeah, sort of.
So I'm sometimes a bit confused. So we have data engineers, we have big data engineers. Is there any difference between these two? Like, or they're mostly synonyms of big data engineers and usual engineers? I mean, usual data engineers.
Like by the book and the way it's supposed to be, a difference in terms of how you process the data. Like big data engineering requires a bit different tools, like heavy load optimizations. Data engineering is more like software engineering on the back end. But in reality, I would say that a lot of companies name big data engineers as data engineers, and it's like constantly a bit confusing because of that.
So many just drop the big part and just
Yeah.
go with data engineer. And is there any difference in tools? Because for example, you say you mentioned Spark, Impala, things like this, and what I see in data engineers maybe is a bit different. Like most of them use Spark as well, but I see more cloud-based things like I don't know streams, Lambda functions, and things like this. Or it's just it depends on the company, and there's no really big difference.
I would say it depends on the company because some companies choose multiple cloud services, some companies build custom solutions, and because of that, data engineers might be more on the side of, for example, parsing data, which is considered to be like more backend thing, or reading from the database, while more big data thing is working with so-called big data specific data formats like Avro, Parquet, and Protobuf. Probably like backend engineers usually work with JSON or maybe a little bit with CSVs.
Okay, so at the end, usually there is not much difference, right?
Yeah.
Okay, and what kind of, I think we talked a bit about tools. So we talked about Spark, Cloud, and you mentioned Scala as well. I think Python is quite popular.
Yeah.
What kind of skills, if we're not talking about specific tools, but more skills or more fundamental skills, what kind of skills they need to be able to do their job?
I would say the most important one is coding skills. It's often that senior level engineers get into big data engineering, which is quite logical because they already have some experience on the backend side, and then they learn big data stack and just understand already how it works behind the scenes. So definitely a great level of coding skills. Another one is working with databases, like writing queries, being able to optimize them. Usually it's SQL databases, sometimes NoSQL. So kind of being able to switch from one to another, because in my experience, when you join different companies, sometimes you have totally different stack or even different project, and you just have to switch real quick. So those would be the main ones. And the one which I also consider important, but sometimes kind of missing out, is infrastructure side skills, like understanding of the networking, for example, being able to know how the racks look like how does it work on the hardware side, why it's important to optimize some of our applications in such a way, and not being afraid of kind of getting into infrastructure side and setting up something, because we do need to do that sometimes.
And what about distributed computing and things like this, like
Yeah,
MapReduce and so, or it's included in databases, sort of.
I would say that kind of now frameworks are on such a high level that sometimes people like don't need to understand that, but I would say that it's quite a basic thing, kind of university stuff.
So, because I remember we at university we studied this MapReduce. I don't think I really used Hadoop after university, so we just covered it at university, and so we learned how to do this, but outside, not really. But it's still important to know these concepts, right?
And I would say it's important to understand them, but in terms of Hadoop, it's getting really outdated lately, because when I was starting out, it was important to understand how it works, like HDFS specifically. But right now, a lot of people, a lot of companies just switch to something else instead of that, because it's easier to maintain some cloud services, for example.
Yeah, indeed. And so we talked about big data engineers. So they take care of data preparation. So there is some data generated by the users of our product. So data engineers, big data engineers take care of processing this data and making it possible for analysts and other people to run their queries. What do data scientists do
I
usually
would
in
say,
this setup?
yeah. The main part would be actually building machine learning models, but it's only one part of the machine learning model cycle, how it's called, because they do need to clean the data, prepare it to build features, create the models, deploy them sometimes. Sometimes it's in their role, sometimes in someone else's, but still they need to understand very well how it's supposed to be deployed. So they would be able to evaluate it further, and it's called a cycle because it can get repeated again if we need to fix some features tune hyperparameters, or just in general go to another solution because this one is not really good for our needs.
Mm-hmm. So clean the data is something that data scientists do. So you cannot expect data engineers to clean data for data scientists, right?
I would say it's a bit controversial because sometimes data engineers do that. Sometimes data scientists need to still have this pre-processing step. Depends on the company as well, or just the way the pipeline is built.
Mm-hmm. And I guess at the end, both do just different kind of cleaning, right?
Yeah.
Okay. And so in terms of responsibilities, I think I have an understanding. In terms of tools, I think data scientists use quite a different set of tools, right, from big data engineers.
Yeah, sometimes they can coincide in Spark because now Spark is getting more and more popular for machine learning as well. And Python is also heavily used by some big data engineers. So they can kind of coincide here, but yeah, mostly machine learning engineers or data scientists would use some multiple specific libraries for a specific model case, whether it's recommendation system, deep learning, or computer vision. And they may not get involved that much with infrastructure, for example. And yeah, databases would be practically the same, especially if data engineers just push the data there and data scientists just read it from there.
And in terms of the programming language, you use Scala.
Yeah.
Do data scientists who you work with, they also use Scala or they use Python?
They use Python, and we kind of communicate through files or data
Mm-hmm.
that we write to database. So therefore, they don't need to go into our source code. But they also have software engineers, kind of machine learning engineers who work with both Scala and Python, depending on the task.
Mm-hmm. Okay, so you produce a file, a Parquet file, for example, and then a data scientist, they know how to read this file using Python, for example, and this is how you
Yeah.
work. So actually, my next question was, how do you work together? I think we partly answered that. So the interface for you is the files that you create. So you create files and data scientists consume these files. But how do you work in general? Do you work in the same team or do you work in different teams? So how the process looks like?
So in my company, we work in different teams. We don't even have that much like connection because we don't really know what data scientists do with the data later. We just deliver it the way they need it. For example, they can just ask to add some field or to build some transformation because it's easier to build it on our side and it would be like less heavy load. In other projects that I saw or that my colleagues worked on in different companies, sometimes they have this specific team where they have a dedicated data engineer or multiple data engineers, and they work closely on each step of the pipeline. So it's kind of different things. And sometimes it just happens the way I work. Like in my career, I didn't really work closely with data scientists, and it just was usually outside of work, like just my interest to see how it works. While my colleagues from previous workplace, for example, that changed the jobs, they constantly work with data scientists closely. So it can be different in this.
Mm-hmm. So if a data scientist needs a new field, would they just go and create a Jira ticket for you? Hey, I need this field, or
Yeah.
something like this? Okay. So this is how you interact. So you sit maybe in different rooms, or I mean,
Yeah.
now we don't have rooms, but different teams, right? And you communicate occasionally through Jira or through maybe some common meetings that you have not very frequently. Okay. And yeah, maybe we can do some sort of a walkthrough of a project. So let's say you want to start a new project, and this project is about machine learning, but you still need to process some data before data scientists can do this. Do you have some ideas what kind of project we can talk about?
We can, for example, take some recommendation system case when, for example, we have kind of a Netflix website where we have different types of data, users' information and history of their ratings, for example, of the movies or just their searches. And we need to recommend some movies for these users. So the part of data engineering would be to extract this data. We could probably build two pipelines, streaming and static or batch processing. we stream in some new data coming in constantly to update the model later, and batch to store the history, and it can be of different formats. And then we would build some kind of transformations to write it to either files like Parquet or CSV for better processing for data scientists, or write some part of the information. For example, we could store the data about movies or users in the database and have the stream information about their ratings. And then we could combine this together, and data scientists would be able to go through this data, which would be, for example, cleaned from duplicates or some zero values, which are a bit confusing later. And they can define which features would play the biggest role, build the machine learning model, and the deploy part kind of depends who does that. Sometimes machine learning engineers, sometimes data scientists themselves, or even data engineers. So someone would deploy the model to production, and then data scientists could evaluate whether the solution works or not and deliver some results. And actually, if it's deployed, some tools like, I don't remember how it's called, but there is this library that is able to be connected to Tableau or write results to the database, and if it's recommendations, and then we can display it in Tableau in such a way other users like data analysts or business users can just visualize the data with some graph charts, while data scientists could kind of present the solution with these results in a more graphic way.
Okay, so we have a Netflix-like website where users can watch movies. So every time a user watches a movie or maybe leave a rating about the movie, so this data ends up in your data pipeline immediately. So you said you have this streaming, you have a stream of data, this kind of data, right? And you have some sort of processing jobs that take this information, take this event, process this, and then put it in some sort of storage like Parquet or CSV.
Yeah.
Right. And then data scientists take this data that you prepared from the events, and they can train a model on that. So I assume if this thing runs maybe for a month, then they take this 1 month of data and train their model, right? And yeah, and you said the data scientists also take care of deploying the model, and then there are some analysts who can look at the results, right?
Yeah.
Okay, and so what kind of tools would you use here, like for Stream, for example? Like, would you use something like Kafka or Kinesis, or what kind of tools would you use here?
Probably I would use Flink. It's quite
Flink.
good for streaming. Spark is not that good, but it's easier to connect Spark and Flink. For example, if you would have a Spark pipeline for batch data processing, like already having some history about users, if the website was created some time ago, we already have some historical data, and streaming for Flink, using Flink, and then you can write the Flink files, for example, in some Parquet to S3 storage, and the Spark pipeline would be stored using database, like historical data about users and movies. And then we can combine the two in either a library, or data scientists could read from both and rely on historical data to build better predictions.
And then they use their data science tools, but then at the end you have a model which they deploy themselves, or you can also help them, because I imagine that if you have this stream of data, maybe this is where you can put this model, or not really.
Yeah, actually, data engineers can help with deploying. For example, there are tools like MLflow, Kubeflow, which I know other teams in my company are using, and therefore they have like dedicated person to that, who is kind of data engineer or machine learning engineer, depends on how each company calls this person. But they work on this more infrastructural side of things, like whether you build an API or you have to work with Kubernetes or cloud services to build the kind of provision for this model service, probably build some container for it. So it's more of backend work than data science work.
Okay, and this person was in the data science team, right? They were helping the data scientists with this engineering work, right?
Yeah, it's kind of the way it works in my company.
Okay, yeah, because we have a question, and yeah, it's quite interesting and related to what we're talking now. How much data scientists should know about data engineering, and what kind of skills they need to have? So you mentioned that you have a dedicated engineer in their team. Does this engineer take care of all the engineering stuff, or still data scientists need to have basic knowledge of data engineering?
In my company, they kind of called machine learning engineers because they do deploy their own models sometimes, and they operate with data. In other teams or other companies, sometimes data scientists only work with machine learning models, but I would say that it's kind of ideal case because startups or new projects usually have this, I call it full stack data science, because they kind of make one person do everything, or at least the part with both model and deployment. So I would say that it's important for data scientists just to have an understanding why some pipelines are built in such a way. And so it would be helpful with assessment of time, for example, or having an understanding how long it might take for them to get the data and how some issues on the data engineering side can influence them. But just in general, I would say that it's only necessary to have the skills if this person has to do the whole pipeline, which also happens sometimes.
Okay, so your data scientists are engineers basically, so they, if they need, they can go and figure out how your pipelines work, right?
Yeah.
But like in general, so you said that it's a good idea that data scientists should know how pipelines are built. Do you know how they can acquire this knowledge, how they can learn how data pipelines are built if you're working in a different team? So data scientists work in one team, you work in another team. So how data scientists can get this knowledge?
I would say that inside a company could be just some knowledge sharing sessions. Like we have, for example, internal engineering meetups where each team sometimes can just talk about the technologies that we use, how we build some solutions. And aside from that, if they are interested in the topic, they can just also learn in some resources like books or courses or some lectures, because I think that it's quite a lot of resources lately on big data engineering, since it's becoming more popular.
Yeah, thanks. And you mentioned that you, in your free time, you're working a bit with data science just to learn a bit of machine learning. And we have a question from Prem. The question is, should data engineers gradually try to transition to become more data scientists? What is your what are your thoughts about this? Like, should data engineers get to know more data science to be better data engineers?
I would say that it's good to know more on the side of how the machine learning cycle works. And for example, I don't really work with internals of how machine learning model works. I don't get into that, but I have knowledge of each step. And recently I started like to learn how to deploy that, how to build the whole pipeline, and so that data scientists would be able to only build machine learning model. So I would say that it's important to understand each step and all the inputs and outputs of those steps, and not that much important to understand how the model actually works. Like we are more on the software engineering side here, like what is the input, what is the output, and what happens next, kind of thing.
So you don't need to go into details of how the exact mathematics or even what kind of model they use inside, but you need to know, okay, this is a model. This is the kind of input it gets. This is the kind of output it produces, and you need to know what actually to do with this. How do you package this thing? How you deploy this thing, and things like this.
Yeah, I don't get much into algorithms, but more like it's important to understand what this model actually does, because it influences the pipeline, like to actually predict what can happen inside the pipeline or in different cases, which can be unexpected.
Do you think it would be beneficial for data engineers to actually learn these internals? Maybe not into details a lot, but at least like, I don't know, how random forest works, how logistic regression works, or like for data engineers, it's not really that important.
I would say that it's not really important. It's more like part of the interest. If it's something that's interesting, like I know some data engineers that are interested in machine learning and they are trying it out. And I think that it's helpful if they work closely with data scientists. And it's also kind of nice to have different perspective, while a lot of data scientists have more mathematical backgrounds and analytical skills, and they kind of come more from software engineering backgrounds and have this point of view, which can be also helpful if people collaborate on building such solutions.
And I guess the same is like if we reversed it, the same is true for data scientists. It's also for them would be beneficial to know the data engineering part of things. Maybe not just, okay, this is how I use this function in PySpark, but maybe a bit more details, right? It's not required for them to do this, but it would be beneficial for them to get some idea how it works underneath, right?
Yeah, I agree here.
Now, and because we have a related question from Steve, what advice would you give to analysts or data scientists who would like to transition into data engineering?
I would say that the most important thing is to work on great level of coding skills. I noticed that I was mentoring a data analyst, and I noticed that she doesn't have the same background in software engineering, and therefore she sometimes couldn't understand how the actual algorithms work, which are quite kind of seem to me basic. And from my perspective, I didn't really understand that she had more like mathematical background. And therefore, I think it's very important to have more experience here and learn on that side. Aside from that, I think kind of databases and some tech stack coincides in general. So maybe a bit of infrastructure side as well, if this person would like to get involved in deployment, for example, and the setup of the jobs.
Mm-hmm. And algorithms is quite broad. So what kind of algorithms do you think would be most beneficial to know? Like just basic data structures and algorithms, or?
Yeah, exactly. Some basic data structures. Sometimes even the code reviews, it comes up that someone could write something in a more performant way, just reusing this knowledge from the algorithms and data structures.
It's like use set instead of list. This kind of thing.
I understand. Yeah.
Okay, and or how hash map works. Things like this. Okay, are there any other things that would be beneficial to know from these algorithms and data structures? Like, would they need to go into graphs, for example, or trees, or not at the beginning?
Depends on the sphere. For example, I got into graphs because I was working with graph databases. There is this NoSQL databases. So before that, you wouldn't need to know much of that. And also it's not that often used. Like in reality, I didn't notice in other companies usage of graph databases. And mostly it's about complexity of algorithms. It's not like just knowing by heart, but understanding why it's better to use this data structure or this algorithm. And also it's a lot in the context of the programming language. Like in some programming languages, it's different. Some data structures named differently, some implemented differently. So it's important to know which one is better to use.
Do you, from the top of your mind, maybe have a list of must-know like data structures that you must know to to get started, like in addition to lists and sets and hash maps that we mentioned?
I kind of get it from Scala. Like we have sequences and lists and arrays, but in functional programming, you don't use arrays much. So it's also different in the way the programming language you use. I would say specific to the language. In Python, they have different namings for the data structures.
Okay, I guess the sequence you mentioned, I think this is like more maybe a linked list, right?
Yeah.
Okay, and then you have a different type of list, which is an array, right? So, okay, and then sets, like when it comes to sets, there are different ways of implementing a set. You can have a tree-based set, or you can have a hash-based set. Do you think it's also like a good knowledge to have, or not really? You just need to know that set is faster than list.
I would say that just knowing that set is faster than list. And in some cases that instead of sorting, you could just use a set. And sometimes people do that.
And when it comes to databases, what kind of databases would you recommend to learn? Just pick any, or?
I think PostgreSQL is the easiest one to start, or MySQL. So it's kind of not that much difference between the two. I would say that it's also nice to have at least one NoSQL database just to understand how it's different from SQL databases, and it's easier then to switch to something else.
Which one would you recommend, Mongo or?
I guess Mongo is the easier to start. I had a lot of fun with Neo4j, but it's very specific. Not that many people use it.
Neo4j is a graph database, right?
Yeah.
Then you also have some Mongo. I think it's called document database. But
Yeah,
you also have like a
based.
different kind of, like there are so many NoSQL databases. So you have this document databases like Mongo, CouchDB. You also have key value databases. Maybe it's a good idea to try to play with at least one. Or
yeah, just understand why it's called like NoSQL, because when you just hear about them, it's hard to understand and map it to reality.
And then from the infrastructure side of things, so I think you mentioned that data engineers need to know networking, and yeah, things like this. But when it comes to data scientists who want to transition, they maybe don't need to get into nitty-gritties of networking and know the how it's called, like this famous OCI stack, right? Yeah. Maybe they don't need to know all the 7 layers by heart. But like, what kind of things they need to know from the infrastructure point of view to know a bit of data engineering to be successful in that?
I think Docker is a must, because data scientists also use Docker, as far as I know, for at least testing or deploying. Also, I would say some tools like cloud services that would help to understand, kind of have this abstraction on top of the hardware, like
which sorry?
Cloud services like AWS Lambda or something like that. I would also recommend Kubernetes, but it kind of has this high learning curve, so it's not for everyone in terms of starting out, but it's necessary to use Kubernetes, and it's becoming more and more popular. I would recommend trying out to learn that.
What's the easiest way to try out Kubernetes?
I think just install and try it out. Like even having a small cluster with one node and setting up something and seeing how it works. For me, the most interesting part is having it more connected to work. Like when I was just setting up databases, it was kind of interesting, but it's not really practical if you don't have to use with that. You don't have to use that, but in data science or data engineering, sometimes you have to deploy some pipelines using Kubernetes, and trying out that sometimes helps to actually learn that as a framework and the pipeline and get a better understanding how it works behind the scenes. Like, for example, Spark and Kubernetes, it's quite useful for future understanding of how Spark would work with other providers of the data.
Okay, so if a data scientist or an analyst want to transition into data engineering, so first they need to know the basic data structures, like list sets, maps, etc. Then they need to pick up one relational database, Postgre or MySQL. Then they need to pick one NoSQL database, for example, Mongo. Play with this. Also try to understand what kind of categories are there in NoSQL databases, because we mentioned document, key value. And then from the infrastructure side, Docker, cloud, and then maybe playing with Kubernetes. Even though there is a high learning curve, it's still useful to try it. And you said you can just install it locally and play with this, right?
Yeah.
Okay. Yeah, thanks. Yeah, so let me see what kind of questions we have. So the question we have, another question we have is, how do you deal with data quality checks? What kind of monitorings do you recommend setting up?
I would say at least monitoring how the data flows in the pipelines. Like, for example, monitoring that today there is no data in this pipeline. or there is like too much data, more than you expected, to monitor spikes of data, which is also important because it helps to optimize pipelines in the future. And it will be good as well to monitor the schema changes, at least, because definitely monitoring data changes, it's way too complicated. But monitoring schema changes, it's quite helpful.
What is that? Schema changes? Like,
for example, in some data formats like overall Parquet or protobuf, they have either separate files with schema, or they are defined in such a way that you can kind of get it separately aside from data and track that it changed or it didn't change, some
like a
kind
new
of
field
versioning.
is added, for example, right? Or removed. This kind
Yeah,
of
or someone renamed something, which also
Mm-hmm.
happens. Like we had this case recently, it was very not cool.
And if that happens, if schema changes, if somebody renames something, what do? You just send an alert and abort your job?
We, in that case, we didn't have a setup for CSV files because they just have this header, and we just noticed that the pipeline doesn't return the same results as it used to in the same amount of data and some empty values, and therefore like debugging lead to knowledge that some naming changed.
So this kind of monitoring, I guess, is more on data engineers. Do
Yeah.
data scientists also need to do a bit of monitoring for their jobs?
I think they can just do the monitoring in terms of whether the model returns the results and whether it's expected results. I would say that another part of monitoring in terms of resources and something like that would be more on data engineers or machine learning engineers. At least it's the way it works in another team where data scientists are in my company.
Do you think tools you would use are the same that data scientists would use and data engineers, or they're different, like tools for monitoring quality?
And I think that it could be the same. Like,
Mm-hmm.
for example, some alerts or metrics gathering for something either visual, like dashboards with Grafana or other tools or Tableau. So I think it's quite universal in this case.
Mm-hmm. Okay, thank you. Yeah, we have an interesting question. So as you said, the data scientists depend on engineers. So let's say if data scientist needs a new field, they would open a Jira ticket for data engineers to add this. Is there anything for which data engineers depend on data scientists?
I think it depends on the workflow. For example, if we would get the results of the models in some way, we would definitely depend on data scientists. Like, for example, right now we depend on either the source of data, which is third-party clients, or the database where another team pushes the data. So we kind of already depend on another team. But on the data scientist side, yeah, definitely if you would get the data from them, for example, the case that we described with recommendations, if you would want to build some reports on that, and before that, we need to do some transformations for other people, for example, analysts, and therefore we could depend on the results of the model.
But I guess like what more happens more often is data scientists depend on data engineers, because to train a model, you need to have some data. And if you don't have data engineers, you don't have data, or data scientists have to somehow get this data, right? So, and because of this dependency on data, it happens more often that data scientists depend on data engineers, right?
Yeah, exactly.
Okay. So we have a question about data documentation. How do you maintain data documentation? Do you think it's important to have it? And what would be your recommendation there?
I would say it's just in general important to have it, but a lot of people don't like to create documentation. Therefore, it's not the case for many companies where I noticed that, especially outsourcing companies, if you have fixed time project or just don't have time for that, as it happens. In general, I would say that at least it's important to have some schemas documented. Like we have that in terms of the fields, like what is this field, what this table has, like what kind of data is stored there, examples of values for each field, which is also helpful if you would see some anomalies there, or just helpful for testing and having like expectations in terms of these values. So yeah, I would say that schema is important, or just documentation in terms of what happens inside of the pipeline.
What tools do you use for that? Would you just create a, I don't know, Excel spreadsheet with that, or maybe use a specialized tool for that? If
We
there are
have
tools.
For schema documentation, we use that as Hive SQL files description. So like description of each field, the name and the type. As for the documentation of pipelines, it's in Confluence, just like documents with some graphs or schemas if it's necessary.
So these Hive SQL files, I think this documentation is optional, but you say that, okay, it's our standard that we put documentation there, right? And then you generate documentation from these files.
Yeah, in such a situation, it's for us just a decision to build this data governance solution and better understanding what kind of data we process and what kind of data we have. It's like just from multiple people having multiple tables and no one knows what's in there.
I assume that data scientists also, they produce a lot of data. So their models produce data. They also need to document the data, right? Do they use the same tool for that?
Yeah, they just use the same Hive description or documentation in Confluence.
So you have a central place for documentation for your data, for data that data scientists produce, and then there is just one central place.
Yeah.
Okay, cool. Thanks. We have a question from Akshat. I think, so that's the question. So how much of data engineering should one ideally know? I think we covered that a bit, but yeah, so we talked about that, like how much data engineering skills data scientists need to know, ideally. But yeah, we were more talking about like if data scientists want to transition into data engineering. But to be able to successfully do work as data scientists, what kind of data engineering skills they should have?
I would say that coding skills, it's also important because I know that some data scientists are more on the mathematical side and they more interested in building algorithms than to write code. And it actually influences the quality of the creation because you can either build just everything, for example, in one notebook, and it would be hard to deploy it in some way, or they would build the whole solution with libraries and, for example, classes in Python, maybe object-oriented programming. So it would be more like software engineering way to do things. And the databases for sure as well, because they do need to read the data or write some results there.
Right. Okay, so basically improve your software engineering skills.
Yeah.
Yeah, I think the trend I see is now most data scientists in most companies that I see, there is a requirement of being a good developer. So maybe they don't need to be as good as software engineers, but they need to be decent with coding. Okay. Yeah, there is a comment about for getting started with Kubernetes. There is a good resource called Katacoda. And I think I saw it. I don't know. Have you seen it, Katacoda?
Yeah, I tried it once. It was in the beginning. It's quite useful. You can just try out different commands and see what happens.
I think I saw one with Kubernetes and one with, I think, Kubeflow, and it's pretty cool. So they just set up a local Kubernetes for you in browser, and then in this browser you get a terminal, like a Linux terminal, and then you can do. You have kubectl there with this Kubernetes, and then you can do, and they basically tell you what you should do, like execute this command, execute that command, and then you get this feeling.
Also, Google Cloud has sometimes some code labs. They have this in documentation, for example, of Kubeflow, where you can try out on each step. And some of them are free, so it's possible to use them. Databricks has this kind of trainings as well, but they are usually paid. Sometimes they allow to use some of them for free, either for some conferences attended, like lately Spark Summit is free, and people who attend the summit can use these trainings for free, some of them.
Thanks. So there is a question that I wanted to ask you, and I just remembered it. So let's say I am graduating from a university. So it was, let's say I was studying, I'm studying, computer science. So I'm graduating from university, I study computer science, and now I need to make a choice. What kind of position I want to work. Do I want to do data science or I want to do data engineering? So which path would you recommend and why? And maybe you can also think how would you suggest people to find out what they are more interested in?
Yeah, and exactly. I would suggest to find out what's more interesting. Why I chose big data engineering is for me, data science was a bit not that determined. I think that software engineers would understand me because it's hard sometimes to explain why machine learning model does what she does and why these results are this way. And big data engineering is more like software engineering, that it's more determined. So for me, I was just in general interested in software engineering, and I wanted to work with some different tools and different tasks. Therefore, big data engineering is a great way for people who are getting bored in backend engineering, or they already just go right from the university and learn more of big data tech and go into big data engineering. If the person would be more interested in building algorithms like mathematics, machine learning, just building kind of fashionable things, like computer vision or deep learning, then it's a good case to start with data science.
Mm-hmm. Is there any project you would recommend people to try to understand if they like data engineering or not? Like, it sounds cool, right? Like if you look, people say, hey, data engineers are so important. Data scientists really depend on them. And many people think, okay, it's cool. I want to become a data engineer. But maybe they don't really understand what this work requires. Do you have any ideas, like maybe a small project they can do to try to find out if they like doing this kind of stuff?
I would say even building a simple word count and getting more transformations on that, or building it in a more complicated way and trying to kind of improve it in each step and building the pipeline around, because there are so many ways you can do that, like either using HDFS like MapReduce standard or Spark, and try to optimize some algorithms. The project which I enjoyed working when I was at the university was just working with streaming data. Like, for example, Twitter has an open API, and you could just read the data and build some analytics on top of that. For example, how many users tweet about this, how many users tweet from this location or another one. And it's quite fun in terms of seeing the results and getting to know how some frameworks work and how you can just deploy it or write the result somewhere, which is a great practical way to see how it works.
Mm-hmm. So this Twitter project, so you have a stream of data from Twitter. So you build a pipeline, a streaming pipeline to process this data and display it in real time, like on some sort of a dashboard.
Yeah, I used
That's cool.
Elasticsearch, which was quite easy to kind of connect it to Spark. Just dump the data into Elasticsearch and have it displayed in Kibana, which is easy to try and also visualize results of work already.
That's a cool project. And this word count, this is just you take a text document and you count how many times each word appears. Do you know any documents that people can take to do this?
I think there are data banks with some text. So the text can be taken. Usually the typical example is some Shakespeare works, but maybe it's more interesting to take some article, for example, big article to process more data, or even some scientific article, for example, as well, and get some words from there and analyze that.
Yeah. Well, Shakespeare, I think it's the opposite of big data. Right? I don't know how many kilobytes are there, but like, even though maybe he was productive, but yeah, not. So one thing I know it's possible to process Wikipedia. It's also a bit challenging because in Wikipedia you have just one big XML file that you need to figure out how to process. But I guess this is kind of things you as a data engineer, as a big data engineer, need to maybe enjoy. Like if you enjoy doing this, like figuring out, okay, I have this big XML file, how do I actually read it, right?
Yeah.
That could be a part of this. Then there is a dataset, maybe you heard, called Common Crawl.
Yeah.
Have you
Also
heard about
familiar.
it? Yeah, I think they just get a copy of the internet. Like there is a crawler, and then they go on the internet and save all the pages they see, and you can just download these pages. And like every month they generate like terabytes or petabytes of data.
Also,
Yeah, sorry.
yeah, there are sometimes some scientific open APIs. Like I found once NASA API about their discoveries or some results from their researches. Like for example, some data from Mars, and kind of can be fun in terms of the topic.
Data from Mars. So they published all the data from Mars.
Yeah, I think partially, like not all of the data, but they published some data from their researches.
Ah, that's cool. Like, do you know if they publish it in real time? No?
Yeah, I think some of them is in streaming because I was looking at the time into streaming APIs.
Yeah, because how cool would it be to build a streaming pipeline to actually get data from Mars and process it?
Yeah.
Maybe it's not super high volume, but it's quite cool.
Also, it's possible to just parse some social media, like Instagram, for example, has an API, and parse some information about the posts, or Facebook.
Mm-hmm. Yeah, right. So in social media, there is so much data. It's good
Yeah.
to be able to take advantage of that. Yeah, we still have some time and we have quite a few questions. So one question is, what are your thoughts on companies that use tools for ETLs instead of hiring data engineers? And what are the advantages of kind of outsourcing this to these companies and use pre-built tools, or hire data engineers and build your own data pipelines?
Okay, so I can say that I have some attitude towards that. I think it's just one way to solve the issue. I would say that I noticed this approach for startups or like projects with fixed time, and you need to deliver something real quick and to get the results like real quick as well. And therefore, it really works well because you can just build, for example, AWS or Google pipeline with all of their services and kind of like constructor details, and that's it. I would say that it doesn't really scale well, in my opinion, that after some time, there's always something that should be customizable in each product. Sometimes you have new features of the product, new parts of the product, and therefore you can't just rely on the cloud services. So it usually works on smaller scale, in my opinion.
Yeah, I remember there's a tool from Microsoft that has this drag and drop interface. You just drag and drop these boxes, components, and you connect them with arrows, and then you say, okay, like you add a deduplication step, you just drag and drop deduplication. Then you also can do this with fuzzy lookup. You can do quite complex pipelines there. But yeah, I guess at some point they become less flexible, right?
Yeah.
So a question from Wes, what are the most challenging tasks for data engineers in their daily work?
I would say one of those is the duplication of data sometimes, because it can be quite a complex condition in terms of how we want to track these duplicates. Another one which I often have to do is historical data reprocessing. It's usually for batch jobs. So for example, there is some mistake 1 month ago in the data, or something changed, and you need to go back in time and kind of remove these data and reprocess it back. And it's complicated because it's always very customizable in comparison to just running a job. You have to set up like some data limits, the ways you want to go back, like the ways the solution changes, and then also see that it actually works well and that you don't need to do that again. And it's very resources consuming because it's usually big periods of time, at least a week or sometimes months or more than that.
Mm-hmm. Yeah, indeed. This historical data reprocessing. Yeah. So do you have like a way of dealing with this, like a standard approach, or like every time you do something different?
Yeah, there is a standard approach, but I would say that it currently has a lot of manual steps, and we are on the way of trying to automate that. And some of those steps require some work from the infrastructure side because of the kind of granted privileges in some systems where you need to delete the data. And yeah, infrastructure team hates this when it happens because it's kind of quite risky to delete some data in production systems and rewrite it.
Yeah, thanks. Yeah, we had a talk recently in DataTalks.Club about that. I think it was called data hysterization, which allows to actually do this. So for those who are interested, maybe you can check. But it's indeed a complex topic. So I remember one slide. There was one slide with the algorithm that describes the process, and it's quite complicated. So maybe,
Also,
yes, sorry, please.
sorry. Delta Lake helps now with Spark for tracking versions of data, which we're also trying to use to kind of automate that and see how the data changed. And you can kind of travel back in time to different versions of data there. It's also useful.
Yeah, right. Thanks. So maybe last question for you. Do you know any course about data engineering that could be useful for data scientists?
I would say that there is this specialization big data on Coursera. It's just called big data specialization. And that's the one where I was starting from. And it was really great because the first course of the specialization is purely theoretical. So if the person doesn't want to go into specific practical tasks, can just go through the first course where all the tools explain the kind of tasks big data engineers do, data formats, everything. So it gives like great understanding and perspective how everything works. And the next courses are more practical on the specific tools and solving specific tasks.
Thank you. Do you have any last words?
Just in general, also I would suggest to use the books as well, because I find it kind of giving more deeper understanding than sometimes courses or lectures. Like there are a lot of books on Spark or big data in general, which kind of cover quite a lot.
Any specific book?
Specifically, I enjoyed Spark books like High Performance Spark or Learning Spark. On big data, I think there is a book by, I don't remember the name, it's about data intensive workloads, something like that.
Building
Just in
data
general,
intensive applications, right?
yeah, something like that, yeah.
Yeah, it has a pig on the cover.
Right? Yeah, also, yeah, our Riley books are great on that.
Yeah, I think the author is Martin Kleppmann and design data intensive applications.
Yeah,
that's a good book. How can people find you?
I am on Twitter, LinkedIn. Also, like you can find my talks on YouTube because most of them are recorded about big data or about Kubernetes as well.
And Alice.
Yeah.
Alice and Kubernetes.
Yeah. In every part.
Yeah. Thanks a lot for joining us today and for sharing your knowledge with us. And thanks everyone for joining us and asking questions. And yeah, just want to remind that tomorrow we have another day, the last day of this conference. We will talk about building a machine learning startup. So don't forget to check it. And yeah, I guess that's all. Thanks.
Thank you. I enjoyed it.
Yes, me too. Have a great evening. Goodbye.
You too. Bye.